Hello, good evening. I welcome you all to this wonderful lesson. So we won't be able to do our live sessions because of network being a problem. But I saw it fit that maybe we may try to look at some pre-recorded videos like this one where I've done a video you're able to go through. So just 2 to 3 days, I think so, the network will be back to normal. So we won't wait for the network, but we'll try to go through some recorded lessons like this one so that we see how we can progress with our lesson. So in today's lesson, I want us to look at vectors, and the first thing that we are going to start with is called the magnitude of a vector. So what you need to understand about this term magnitude of a vector is that the magnitude is just the same as the what? The modulus. So these two are just the same. Magnitude and modulus are just the same. So if you are told to find the modulus or find the magnitude, is just one and the same thing. So you know that magnitude, for example, you are given a vector u is equal to, so let's say you've got x there and y. This is what a vector is. You are given this type of a vector. So when I say modulus, it's just the same as telling you something like this. Have you seen? This is the modulus of u. So whenever you say something like this, it is just same as telling you to find the what? The magnitude. This is the interpretation. It is just the same as you are told to find the magnitude. So this is just the same. So in an exam, sometimes they will tell you find the magnitude of this. Sometimes you just find something that is just like this one. You are just given something like that. So make sure you understand that. Make sure that you know that particular part. So there is a particular formula that we get to use. So whenever you are told to find something like this, it's just the length of u to a scale used. This is what is meaning. So the length of u to a scale that is used. So a formula that is used, you say the modulus of u, in that case, the modulus of vector u is equal to the square root of x, you get the x, you square it, plus you even get the y, you do what? You square it. So this means that whenever you are given a question in an exam, this is a particular formula that you are going to use. You are going to use this formula to work out questions. This is what you are supposed to do, and these are some of the things that you need to get and understand. So the meaning of this, you may be given something like this. You are given a graph. So you need to understand it also in this way. You may just be given something. You are just given something that is like this. Have you seen? You are given something, the point here. Let's say this is point A. The point that is there is B. Have you seen? Then you just find the question to say, so these are points. So let me say, let me put here a 2. Let me put there a 4. So I'm going to do this. I put there a 4 like this. Even here 0. Let me put here 3. I put there what? 6. This is what I'm going to do. And the question is just telling you to say find. You just find the question that find AB like this. Then you find the modulus of AB. You just find something like this. So the way you are going to do, since you know that this is a formula to use, you know, okay, the way this one is, have you seen, if you were to do this, you do this, have you seen? Even here, you join them like this. You are going to form something that will look like this. Have you seen? This is what you're going to form. So which means that you find the difference it is making in the y-axis. So you find the difference. You can say this is x1, this is what? Y2. Even on the y-axis, have you seen there is this difference that is being covered there? There is that difference that is being covered. So you can say, okay, from here, I will say this is what? Y1. Going that side on top there, that is what? Y2. You find the difference on the y-axis and the difference on what? X-axis, like that. So meaning that whenever you see points like this, whenever you see a particular question in this nature, so a point that is here, you know that this is what? 3, 2. So where you say A there, you know it is what? 3, comma 2. Then B, the coordinate for B on top there, it is what? It is 6 comma what? 6 comma 4. Have you seen? You've got something like that. So this is a point that is there. This is the point that is there. Then you say this is x1, this is y1. This is x2, you say this is what? This is y2. You are going to do something like this. From here now, that's where you get to now apply the formula where you are going to say the modulus of AB is equal to, so modulus of AB is equal to, you find the difference on the x-axis, you say x2 minus x1 cross, then you put a square there. Then you say plus what? Y2 minus y1. You do this. That's when you do what? That's when you square like that. So meaning that this is a particular formula that you get to use if points are given in coordinates. So you've got a coordinate here. So you are able to agree with me that if you want to go forward, you can just say y2, x2 is 6, x1 is 3, which is 6 minus 3. The one that is here, have you seen? So we are just saying 6 minus what? 6 minus 3. You do this. You put a square there. You know that x2 is 6. x1, it is 3. You say plus, what is the y2? y2 is 4 minus, what is y1? y1 is 2, like this. So you've got something that is like this, where you've got here you are going to have 3 squared plus what? 2 squared. You are going to have something like that. If you evaluate this, you discover that the answer you are going to get will be like this. So the answer that you are going to get, you are going to have something like 9 plus 4, which is what? Which is 13. You're going to have a 13. So 13 there. So meaning that this is the what? This is the modulus or the magnitude of that vector. But in a case where you are just given a one coordinate, it is very simple. For example, I just tell you to say that A is equal to, if A is equal to, I just say, okay, let me put a 4 there and a 3. You are just given something like this. And you are taught to find the modulus of A. This is where now you just get the way they are. You just say this is equal to, you just say the square root of x squared plus what? Y squared. This is what you are going to do. Where you say this is just the same as x is this one. So 4 squared plus 3 squared. What answer you get in there? What is your answer? The answer that you are going to get will be what? This is 16 plus 9, you get a 25. So 25 square root of 25, that is 5. So you just say 5 what? 5 units. This is what you are going to do. This is what we get to do. These are some of the things that you need to understand. So if you are given 2 points or you are just given 1 point, you know what to do. So I want you to understand this. I want you to get everything that I am saying. So this is how the questions get to come in an exam. This is how you need to understand some of these things. So even as we proceed and look at another part, so I want us to look at another different part called how to determine collinearity of points, where we get to look at the parallel vectors and the other one, which is collinear vectors. This is something that I want us to look at. So let us now proceed and look at that. We proceed and see how we are going to understand this new part that I've just introduced. So I've said we look at parallel vectors. What I mean when I say these are parallel vectors. So when I say parallel what? Parallel vectors, what do I mean? So what I get to mean is that when 2 vectors are parallel, this is what you need to know. This is what you need to understand. When 2 vectors are parallel, it means that they are just the same. They may just differ with a scalar. I believe you know what I mean by scalar. Where you are, maybe you've got A is equal to, you've got a vector A. So vector A can be maybe 2 there and 4 there. Then you may have B, which can be something like you are given a 3 there, but inside there you've got 2 and a 4. Have you seen? You've got something like this. it means that these two vectors are parallel. This is the meaning. So these two vectors are parallel. They are just differing by what? By a scalar. They are just differing by a what? By that scalar. So the difference is the scalar that is being used. That is the difference. In other words, this can also be like this. Sometimes you might not be able to see this. So they will just give you something like this. They will just tell you, okay, A is equal to, so I want to make you understand, 4, 2, 4 there. And you've got the B, which is something like this. The B, there 6, there 12. Have you seen like this? So you know that, okay, for you to make this one to be like this, you need to factor out something that is common. You know that, okay, it is the 3. That's why I had to factor out that 3. Have you seen like this? This is the meaning. So if two vectors are the same, they may just differ with a scalar. It means that those two vectors are what? Are parallel. We call them parallel what? Parallel vectors. So this is what you need to know. This is what you need to understand. So when I say these are parallel vectors, this is what I get to mean. These are two parallel vectors. They are just differing with a scalar. That scalar, which is what? 3. Here there is 1. There is what? 3. Have you seen? This is the meaning. So now you are able to agree that these are the same. You can further even evaluate this, even that, so that they may be similar. Have you seen? So this is what I get to mean. So that is the meaning. If two vectors are parallel, meaning that if one is a scalar multiple with a scalar multiple of the other, this is what you need to know and understand. So this is just something that you need to know. This is something that you need to get and understand. So now, what do we mean now by collinear? We go to collinear. What do we mean when we say that these are collinear vectors? What do we mean when we say these are collinear vectors? So what we mean when I say that these are collinear vectors, if two vectors are more parallel vectors, we get to say that they are called what? Collinear, because they get to lie on the same line. So you've got something that is like this. This is what you have. You've got something that is like this. You are given something. And you've got a vector that is this, like this. So you've got points now that are running like this. Let's say from here you've got B. There you've got, let's say there, I don't know if we're able to see, there we've got A. Then on this particular point we also have C. And these are going that way. Have you seen? So you know that this is the x-axis, this is the y-axis. You've got something that is like this. So these vectors are said to be what? These vectors are said to be collinear because they are lying on the what? On the same line. This is what you need to know and understand. They are lying on the what? They are lying on the same line. So this is the meaning. So when we say these vectors are collinear, it means that they are lying on the what? On the same line. They get to lie on the same line. So now, how do you show that these points are collinear? These points are collinear. How do you get to show that? Or how can you represent that on a particular question? You get to agree with me that certain questions that do come in an exam, you will be asked to show that these 2 points are collinear. So there is something that you need to know. There is something that you need to understand. Let's say you are given points P. You are given these points P, Q, and R. The same way you are given A, B, C. So let's say you are given these 3 points which are given here. So you discover that the directed line segment of this one is what? Is you PQ like this. You've got QR like that and PR like that. And what? And PR like this. Meaning that they are what? They are collinear. These ones are collinear. So now what we get to do, or what we get to prove this, is that, so meaning that the line segment of this is what? Collinear. In a case where we've got A, B, and C, This means that if we get to have, so we are going to have AB, BC, and AC. It means that these are what? These are collinear vectors. They are lying on the same what? On the same graph, on the same line. This is the line. So we are talking about AB, vector AB, and vector what? We've got vector BC, even vector AC. Vector what? AC, like this. These are called collinear what? Collinear vectors. So what you need to understand that it should be noted that any of the 2 points can be expressed as a scalar multiple of each other. So you now discover that there exists a scalar k such that whenever we've got AB here, whenever we've got AB and let's say and BC, we've got AB and BC, we should have something like AB, something AB is equal to what? KBC. Have you seen? This is the what? This is the meaning, and this is what you are supposed to understand. This can also be what? This can also be written the other way around, where you get to say AB like this. AB is equal to what? You've got a scalar now, a scalar k, any number. It can be any number k, where we say a what? AC like this. It can also be written in this manner, or the other way around, where we start with BC equal to KAC. It is just one and the same. So you now discover that this, whenever you've got something like this, you must be able to note something like this. It means that these ones are what? These ones are collinear. Have you seen? These ones get to be what? Collinear. They are lying on the same line. So now you can now conclude that all collinear vectors are parallel, but not all parallel vectors are collinear. Hope you are able to see some similarities. So I've told you that all collinear vectors are parallel, but not all parallel vectors are collinear. This is what you need to understand. Have you seen? We are using the same concept for what? The same concept for parallel to show that the points are what? Collinear. The same way I explained on parallel vectors. This is the same thing. So I'm telling you that all collinear vectors are what? Are parallel. But not all parallel vectors are collinear. That you need to know. So we are going to look at certain questions, certain exam questions, the way we get to show them, how we get to prove them that these ones are collinear, these ones are not collinear, or they are parallel. There are certain things that we get to do. There are some things that you need to know and understand. So now, let us look at an exam question. We see how questions get to come in an exam. Just a simple exam question, we see how they come. Okay, so we've got this question that is here. So this question, ECZ 2018 August paper 2. So it came in 2018 for the GCE candidates. So as you can see, with this is a question that is here. They are telling us to say that, show that the points L, which is a coordinate there, this is also a coordinate, this is also a coordinate. So you get to show this in two ways. So for you to show that these points, show that the points blah blah and these are collinear. So are what? Are collinear like this. You are given this particular question. You want to show that these ones are collinear, these points, so 1, 2, 3. So they want you to prove that they all lie on the same line. So how do you get to show this? What are some of the ways that you get to follow if you want to answer that particular question? So what you need to do is this is what you are supposed to do. You get to answer this question in two ways, but we are looking at vectors, so I'm going to go the vector way. So the other way in which you get to show this, just find the gradient of, so I believe you know how we get to find the gradient. Find the gradient of what? LM, find the gradient of MN and LN. If you find the gradient, you discover that the gradient will just be the same. The gradient of these points will just be the same. You now will find the gradient. The gradient is equal to, you say y2 minus y1 over x2 minus x1. So where you get these 2 points, you find the gradient using this particular formula. So you discover that if you solve the gradient way, you are going to find the gradient 3, even here the gradient to be 3, even there the gradient to be 3, if you get to solve that. Have you seen if you use the gradient way? So gradient, you are going to have the same gradient, which you therefore now conclude that since the gradient is the same, it means that these points lie on the same line, hence they are what? Collinear. So you get to show part. This one you show it, this one you show it, even this one you show it. I believe you know how to find the gradient when 2 points are given. So if you are solving for this one, you say this is x1, y1, x2, y2, just like that. So on this particular question now, the way this one is, what we get to do, or what you are supposed to do, is something different. So these are points, so we can turn them to be what? Vectors. So what we are going to do is that this one, the way it is, we've got what? We've got L. So what is L? You are given the L there, which is -2, -10. You are given that vector. We are going to say that that is a vector. Then M, you are given M, which is what? M is 2 and 2 there. Then you are given N. N is what? These are points that you are given. 5 and what? 11. So what we are going to do for us to show that these points are collinear, what we are going to do is that we are going to find vector what? Vector M, LM. This is the vector we are going to find. Aside finding this and that one, so MN, this is what we are going to do. And the last one that we are going to find is where you get this one and that one. Have you seen? You say L and N like this. This is what you are going to do. So you find the vector for that one, the vector for that one, even the vector for that one. So this is what we are going to start. So let's start. So what we are supposed to do, or what we need to get and understand, is something that is very simple. So what we get to do, if I go to these ones, have you seen? If I go to these two, I'm talking about these two. So meaning that I don't know if you are going to understand it this way. So I want your total attention, and I want you to be very observant and very attentive to this point that I'm about to explain here. So on this one, you say, okay, the formula that you are going to use to find this is a formula. We say you are going to say that it is x2 minus what? X1. Then down here, y2 minus y1. This is what you are going to do. You subtract what is given on top. Have you seen? So this is just the same as what you say. Okay, so what I'm going to start with, I'm going to say that 2 minus that one. Have you seen? This one minus that one. You say 2 minus -2. This is what you are going to do. Even down here, 2 minus negative what? -10. That is what you are going to do. So these are ways that you are going to answer these particular questions, where you know that this part that is here, definitely you are going to get, this is 4 there. Negative times negative positive, you are going to have a positive. 2 plus 2, 4. Here you are going to have a positive 2 plus 10, that is 12. So this is the what? This is the answer for this one. So this is what you get to do. You also go to that other one. So if you are following attentively, I want you to follow this. I want you to get, you go to this one. This is what? MN. So MN, what are we going to do? Same procedure, MN. So you are going to say that 5 minus what? 2, 11 minus 2. Obviously, so I'm going to be fast on this. But we are just subtracting the one that is in front minus what is behind, like that. So minus 2, 11 minus 2. What answer are we going to get there? So what is our answer there? Here we're going to have a 3, then there we're going to have 9 like this. Have you seen? This is what you are going to have. We move to the other one, the last one, which is what? NM, like this. This is equal to what? So what are we doing? So we are saying that this is what we are saying. So I want you to be very attentive. We are saying LN. So 5 minus negative 2. What is 5 minus 5 minus negative 2? And we are saying what? 11. So we've got 11 minus negative 10. What is on top? On top. What is down? Down, like that. So what answer are we getting all together here when we work out that? I want you to understand this. So when we work out that, what answer are we going to get? Here, you're going to have a 7. Here, plus, you're going to get 21. So these are the answers that we found. How many are there? We've got 1, 2, and 3. Have you seen the way they are? So I remember telling you that to show that two points are collinear, it means that those lines are parallel to each other. They may just differ with a constant. So all collinear points are parallel, but not all parallel points are what? Are collinear. This point you need to understand it. You need to make sure that you understand it very well. So I want you to know this. So we try to get these points. So we are going to get that the points that are given. So we get the what? We get the points that are given. So what points are there? What points are we given? What points are we given? We are given 4, 12 there. This one that is here, you are able to see it like that. Have you seen? So this is what you need to know and understand. So you are given this. Let me write them properly here so that each one of you are able to see them. So these are the points that we found. So I'm going to do this. Hope you've taken note of these. We are answering these things together. So we say we, don't say I am. So the answer for this one. So the answer for this one. What was the answer? So what was the answer? The answer was 4, 12. The answer was like that. And we moved to MN. What was the answer? 3, 11. These are the, 3, 9. Then we go to LN. What was the answer? The answer was what? 7, isn't it? You had a 7 there and 21, like this. These are the answers. So you try to factorize these. You express them in their lowest terms. Have you seen? This one can also be written as what? This one can also be written as what? 4 is common, isn't it? You do this. 4 there, it is 1. 4 there, it is 3. You go to this one. 3 is able to go there. 3 into 3, 1. 3 into 9, it is 3. Have you seen like this? This is also equal to 7 is able to go there. Then you've got what? This 7 into 7, 1. 7 into 21, it is 3. Have you seen that we are all having what? 1 over 3, 1 over 3, 1 over 3. Have you seen? I believe you are able to follow. You are able to see what is happening. So just us doing this, this is a sign that these points. So since each of the 3 vectors is a scalar multiple of the column vector, which is 1 over what? 1, then 3. 1, 3. So they are multiples of a column vector of that one. And considering that these points, the way they are given, we can now conclude that they are what? These are collinear. They are collinear to each other. So this is what you are supposed to do. This is what you need to understand. So you just say, since all of them are a column scalar multiple of this one. Have you seen? All of them, they're having this one, having this, and this one. You just conclude, since they have 1 over 3 as a scalar multiple of each. Scalar what? Multiple. As a scalar multiple of each. Hence, they are what? Collinear. Just say, hence, they are what? Hence, they are collinear. This is what we get to do. So this is what you need to show. So even when I give you different vectors, This is what you're going to do. You just try to factorize the same way we were doing that, so that we show that, okay, this is just one and the same. So this is what we get to show Collinear what? Collinear points. So now, how do we answer vectors in an exam? So this is a full lesson on vectors. I want you to understand this. I want you to know each and every detail that I'll be explaining in this particular lesson. So I want you to get this. I want you to understand this. I know that we are having challenge with the network currently for the past 2 days. So that's the reason why I decided that, okay, instead of just waiting for the network, at least we need to be doing something. We need to be doing something. And this is what we are actually doing here. Instead of us to be waiting for the network, at least we are doing something. These are recorded lessons that I decided to do, because I want to make sure that we all pass. This year you just have to pass no matter what. Okay, let us look at example 2. So this is an exam question that I want us to answer together. Let's see how we can answer this particular question, something that is like this. How can we work out this question, or what are some of the things that we need to put into consideration? So first thing, you understand what you are given there. They are telling you that AX is this one to be given there. So AX is what? 3. You put a 3 there. So this is the meaning. You put a 3 there. Then you are given XB. XB is this one, which is a 1. You are given a 1 there. So now what you are supposed to do, this O line AB is 4. Have you seen? This is as how it is. The first question, they are telling you to find BO. So the way we get to move, maybe it is your first time learning vectors. So the way we get to move, we just move in this way. You say you move in a triangle way. Just 1, 2. Have you seen? You move from this point to that point, and from that point to that. This is how we get to move. So you say 1, then 2. This is how we get to move. So we move in a triangle way. This is how we get to move. So what I'm going to do is that when I'm told to find BO, so I'm told to find BO what? BO, vector BO. How am I going to move for me to move from B to O? So if I want to find BO, this is the vector that I want to find. So what is BO? BO, I will not even move, because BO is given. It's just the opposite of this vector. Have you seen? Opposite of this one. So this one, the moving of this in a triangle way, it will not work, because I'm given here. This is the opposite of that vector. So it is just what? Negative B as my answer. I move to this one, AB. How can I find AB? In which way can I find AB? AB. Am I given anything here? No, I'm not given anything. So this is the one that I'm going to say AO or B. So I'll move from here. You are told to move from A to B. So what you are going to do is that you are going to move from A to O. Then from O, you proceed to B. So you say this will now be equal to what? AO plus what? OB. This is what you are going to do. So this is AB is now equal to, AB is now equal to, what is AO? Negative vector there, you are going against. So each time we are going against a vector, we say negative what? Negative A. So this is what I'm going to say. Then plus OB. OB. I'm going with a vector. So it just be like this. So meaning that this is my answer. You can end there. There is no problem. You just need to end there. You can end there. But to some people, they'll finish here. They say, okay, I'm not supposed to put that negative. They end here like this. It is just one and the same. Don't be confused. They are trying to hide that negative. So if you want, you can end here. If you don't want complications, we move to this one, which is AX. You are told to find AX. How can you find AX? We want to find AX. How can we find AX? So what you need to know and get is that the AX you are told to find is along this line AB. So AX, you are given something like that. Have you seen? So you can't move AOX. You don't have OX. So you can't say AOX. You can't move that way because you are going to have two unknown values. You don't know this one you don't know. Even this one also you don't know. So it's better you just go direct. You know that AX is along the line what? AB. Then the line AB total is what? 1 plus 3, that is 4. Have you seen? So AX is just 3 of the total line, which is 4. Which line is that? AB. This is what you're going to do. Vector what? AB. So this is what you are going to do. From there now, that's when you get to continue and say that AX is now equal to what? AX is now equal to, you just say 3 over what? 3 over 4. Then AB, you know that it is that one, where you say negative vector A plus vector B, like this. So meaning that this is your what? This is your answer. This is what you're supposed to do. This is your answer, just like this. So these are ways that you need to put. These are methods that you need to get and understand. Just like this, you've solved this particular question. So we are going to do a lot of things together. We are going to solve some good questions together and see how we get to go about these questions. So I guess the network will be back to normal tomorrow. I'm just hoping for the network to come back to normal so that we get to continue with our live sessions, where if you are not clear, you are able to ask questions. I move to this one. I'm told to find OX. So I'm on the last one now, where I'm told to find OX. How can I find OX? So how do we find OX? So this is now what you are going to do. So you say, okay, I want to find OX. I can say OBX. The next question is that, do you have BX? No, avoid this. You can't go this way. AO, you say AO plus what? AX. AX. Do you have AX? Yes, it is the one that I'm just from finding. So AX we have. So we just say, okay, this is now equal to, what is OA? It is what? Vector A, like this. Then plus AX. AX is what? This is AX, which is what? 3 over 4, then negative A plus what? B, like this. Then you try to work out this, you try to simplify. So how are you going to simplify that? This is what you're going to say. Okay, say this is A. So negative 3 times the negative A, you're going to get negative 3 over 4, then you put your A there. Then you say, okay, plus, since this is a positive and that is a positive, so 3 over 4, then the B will just drop there. So only a negative here is, has been affected because of that negative on A. So we work out this part. Have you seen? This is the part that we are going to work out because these are like terms. So I say, okay, this one, I can just do this. For me to work out that one, I can just say this. I will just say, okay, the coefficient there, it is 1 minus 3 over 4. So over 1. What is the common denominator there? It is 4. 1 into 4, it is 4. 4 times 1, it is 4. Minus 4 into 4, it is 1. 1 times 3, it is 3. So what answer are you getting there? 1. 4 minus 3, it is 1 over 4. So we are getting 1 over 4. So it is the answer that is here. We say 1 over what? 1 over 4, then vector A. Since we are having AA, vector A plus what? 3 over 4. We've got a B here, so I put my B there, which I can now therefore conclude that OX is now equal to, I can write this one. Since 4 down is the same, So it's better I just put it here outside. Then I just say, okay, I'm going to have here, when I remove 1 over 4, you just write what is on top, since the 4 which is down has been removed. So you just write what is on top. That is A plus what? 3B, like this. So meaning that this is your what? This is your answer. These are ways or methods that we get to use for us to work out this. Have you seen? So this is what we are supposed to do. These are some of the things that we need to know and understand. So just like this, you know how to answer questions under vectors. So these are methods that need to be used. This is what you need to get and understand. I know someone can come across this. I know you people get to share to your friends. So you can give your friends this number if they want to join my academy, which is an online academy. This is the number they need to call if they want to be part of us. So this is the number that needs to be called. So you need to call me on this same number, which is what? Plus 2609. So plus 260971066747. This is my number. Thank you so much. Let me now give you an exercise. I see how you are going to handle it. I see how you are going to answer it if you've understood the little information that I've shared in this particular video. Thank you so much.